questions at the start. So far, we've only based our choice to fit a line to a set of data based on R. Do you remember what that coefficient was called? It started with a P. What was the person's name? Pearson's correlation coefficient R. Do you remember what Pearson's indicated? If it was close to 1, what could we say about the correlation?
It was strong.
Strong. So Pearson's indicated strength. And what did the sign of Pearson's indicate? Because that was one of the 5 characteristics of the correlation. We had strength, started with a D, like what way it was pointing? Direction. Right now, all I have taught you about is we interpret a correlation based on R, only based on strength and direction. But there's some situations where only using R hides the existence of other more appropriate relationships. Look at this graph here. Have I done a linear regression through that with a blue line? Are those red dots real close to that blue line? So if I was to look at that, I don't need the exact number, but what would R be? Like, would it be close to 1? Would it be pretty high? Close to 1? So if it was close to 1, that would indicate it's a positive direction and that it's a strong correlation. That is all I have taught you so far. We haven't said anything wrong there. But today's lesson is about disrupting the status quo. Because everything in our blood, in our body, in our learning so far is saying that that's all we need to do. A line is great for this. But if you look at those dots, you have a dot that's a bit above the line. And then you have a dot that's only a little bit above the line. Then you have a dot that's a little bit below. And then you have a dot that's further below. Then you have a dot that's only a little bit below, a little bit above and above. Wouldn't a curve fit that better? Could I draw a slightly curved line through this and it would meet the dots? It would be closer to the dots. Okay, that was the worst drawing of a line ever, but it's like... but it's not horizontal. So today's lesson is about that. What do we do in that case? So there is a type of graph called a residual plot that indicates the vertical distance, otherwise known as the residual, between the actual data and the prediction made by the line of best fit. The easiest way to understand this is to just give you like a one for us to play around with. So imagine that I've got this real data represented by red dots here, and I've run a line of best fit through it, a linear regression. Do you agree that that line of best fit, is that line of best fit below the actual red dot on the left there? Is the line of best fit slightly above the second red dot? Is it way below the third red dot? It's slightly above the fourth red dot? So basically what this is, a residual is that purple distance between the actual bit of data and what the line thinks the data should be. So you could summarize that as this is the Y actual data. And this point here on the line is the Y predicted data. Your equation is saying that, okay, we think the line of best fit says the data should be there on the line when really the actual data is above that. So add those on, but let's plot the residual so you can see what we're leading into, a residual plot. So this actual data, that's just the kind of graphs that you've been plotting. It's just a scatter plot. But I'm using this to illustrate what a residual plot is. A residual plot tells you how far the dots are away from the line of best fit. So you can almost imagine the x-axis on a residual plot is like the line of best fit. So the residuals would be, so on the residual plot, can you see how the scale of the actual data is the same as the scale of the residual plot? It goes up to 13. That's meant to be. They're meant to be the same. Where horizontally is the first bit of data? It's just under 2. And so the dot for that residual, is that residual positive? Is the actual bit of data higher than what the line predicts? So if I did a higher bit of data, y actual, minus a lower bit of data, I'm going to get a positive residual. So the residual would sit just below 2 and it would be above 0. So we don't know the units of this scale yet, so I'm just eyeing it. You would have a dot just below 2 and it would be positive. Where would the dot go on the residual plot for the second bit of data on the scatter plot? Would it be still above the horizontal line on the residual plot, or would it be below by a lot or below by a little bit?
Just a little.
Just a little bit. And whereabouts would it be? It would just be above 4 because that's where that data was on the actual scatter plot. So it would just be below 4. What would the next residual look like? Someone over there. Horizontally, it'd be about 6. Would it be above the horizontal line on the residual plot or below it? Above? Way above? Or at least more above than this one here?
Yeah, just a little.
More above? Because this dot is more above the line than this one is. So at 6, it would be more, higher. Next dot over, if I was representing on the residual plot, the residual for this, would it be positive or negative? Negative, just a little bit. And it would be between 8 and 9. Between 8 and 9, just a little bit. Pretty much the same as the other negative one there. The fifth one, positive or negative. What would the residual look like for this one here? Negative, more negative than the last one. And it would be just above 10. So let's say there. And then the last bit of data, is that going to be positive or negative? Positive, but only slightly, and it's between 11 and 12. Hopefully that illustrates to you what a residual plot is. You can almost imagine this graph, which is a whole thing called a residual plot, is almost a picture of the line of best fit and how far these dots are above and below. They rotated this to become straight, okay? From this, you can see a residual plot basically shows you how far above and below data points lie from the line of best fit drawn through them. What do we see about the features of the residual plot? The horizontal x-axis needs to be the same length and scale as the scatter plot you're drawing. The vertical axis is placed so that the x-axis is in the middle and 0 is in the middle as well. The scale should fit the residuals for the data. You'll decide the scale of the y-axis when we actually calculate the residuals. And then you place dots according to the data points and their matching residuals. That's on your notes. You don't need to add anything to that. What I want to do is actually calculate some. So these are your instructions for how you calculate residuals. I'm going to skip back and forth so we can do a question and find them straight away. So how do I find residuals for the data set? Ensure you've entered your X and Y data in. How do I enter data on the calculator? I keep hammering you about this. What do I press to enter data? Start, edit, put data in. Okay? What do you do after that? Once you have completed a linear regression of that data, how do you do a linear regression? You put the data in, you go stat, you go to the right calc, and then you do a lin reg. You must do a lin reg on the data. Okay? And then after that, you go stat edit again. Stat edit, imagine there was data in L1 and L2. You go into the title of L3. You select L3 and you press second stat. Can you see how above stat there's list in blue? Okay? You'll go second stat. And right now, because we haven't actually run data in it, there is no 7 resid. But when we do an example, you'll see. Okay? So you can see that because it's got old data in there. So what I'd like to do, question before I skip over.
Do we have to have diagnostic on as well?
You'll see when the question hits. Okay? So I'm going to keep diagnostic off right now. We'll see what happens. I'm going to skip over interpreting residual plots because we'll do that last. Can you guys enter this data into your calculator? So stat, edit. It's going to be silent on the YouTube while I enter the data. It's 1 to 7. Yep. Does anyone else need a spare? Did you need one? Can I have those 4 back, please, after? Just practice entering the data. What's that habit that our friend just said out loud? What's the habit that you should try to form entering the data? Where should X go? L1. Where should the Y data go? L2. Question? Or was you just raising your hand? So I've entered the data. In our example question, find the least squares line, that's the line of best fit, and state the value of R squared. The question is asking me to find R squared. My diagnostics aren't on right now. So if I did stat, calc, lin, reg, it's going to tell me the line of best fit. It's going to answer part of that question, but I don't currently know what R squared is. So you tell me how to turn diagnostics on. I press something. Anyone? Catalog. How do I access the catalog? Yes? Second 0. How do I skip down to the D's? Press the green D so that I can find the D straight away instead of scrolling to everything. Turn the diagnostics on. Make sure you press enter so it says done. Now I'm going to be able to find R and R squared. So stat, edit, calc again, lin, reg. So at this point, what has the calculator done? It has plotted the points and it drew a line of best fit through that. The calculator, when you do lin reg, it just did this. It drew that line of best fit through the dots. Now we can find the residuals. If it didn't draw this line of best fit, how is it going to find residuals? It doesn't know, it doesn't have a line to say where the data is above and below. So now we've done a line of best fit. You can follow these steps here. Go stat again. You go edit. You go to L3. And what we're telling the calculator, in L3, can you put the residuals in there? So you go second, blue list over stat. Can you see resid popped up? Before there wasn't resid there. Why? Because I didn't ask it to do anything to any data. Now I asked it to draw a line through the data. There's going to be residuals there. So now select 7 resid. It found it for me. I don't have to go data, take another number. It found the residuals for me. So we can draw the residual plot here. Construct a residual plot for the data set. So what do my X data start from? 1, and it goes up to 7. So what should my X-axis be on the residual plot? 1 to 7. Set that. 0, 1, 2, 3, 4, 5, 6, 7. That's my X data. Sorry, I didn't actually answer question A. Find the least squares line and tell me R squared. I didn't write that. R squared was R squared equals 0.9926 to 4 dp. Okay, let's continue finding that residual plot. So remember how before I didn't actually tell you how to find the y-axis? Why? Because what's in L3 decides what your y-axis has to be. What's the biggest positive number in my residuals? What's the biggest positive number in L3? 0.236. This one. She's found that that's the biggest positive number that my graph needs to support. What's the biggest negative number my graph needs to support? Look at the bottom. Is that bottom one the biggest negative number? So I just need a graph that's going to be able to fit positive 0.25, nice round number, above 0.23, and something that fits negative 0.25. So what if this was negative 1, this was negative 2, So halfway would be negative 0.1, negative 0.2, and so halfway between would be negative 0.25. What about above? If it was 0.1, if this was 0.2, 2 above that would be 0.25, would it not? Is that going to fit my residuals there, that scale? Because 0.2, so this would be 0.15, this would be 0.5, 0.05, negative 0.05, negative 0.15. There, that's my Y scale decided. How did I decide my Y scale? I looked at the data that I needed to graph. So what is the residual for x is equal to 1? It tells me negative 0.23. So I'm going to have to draw a dot. At 1, I'm going to go down. Negative 0.2 is there. 0.23 sort of there. Between 0.2 and 0.25. I've done the first one. Go down. When x is 2, residual, negative 0.025. So that's going to be there. 2 residuals drawn. Third residual there. Is that positive or is that negative? Positive. That's going to be above the horizontal line. 0.13. So 0.13, somewhere around there. Between 0.1 and 0.15. We are not getting a microscope out to work out that you've placed the dot at exactly where 0.1304 is. It just needs to be in the general right area. It needs to make sense that it's there, okay? 0.2357, so that's positive for 0.2357, somewhere around there. 5, 0.1411. 0.1411. 6 is a tiny number, but it's negative. So it's just going to be 0.004. That's going to be like there. And then the 7, negative 0.248. Oh, my exercises are in the way. 0.248. Just as long as I don't exceed negative 0.25. That's a residual plot. Can you just spend a couple of minutes to get that plot matching mine, and then we'll skip back to the slides that we missed to discuss what that means. Sorry? Did you do a lin reg? Put the data in. Stack out lin reg the data. So the calculator is not going to line up that skip through it. So now stat calc. Stat edit. Go to L3. Second stat for list. I reckon you didn't do the lin reg. What you did is put the dots in, but you never asked the calculator to put the line through it, which would tell it, oh, this is how far above or below.
I have a issue. I figured out how to fix it. Yeah. So I just figured out how to test it.
All right, can I just have your attention again, please? So you might ask, why did we skip? Wait, so we constructed a residual plot. We did that. We did A. How do I answer C? C comes from the slides that we skipped. Because one of the things that SAYS asks you to do is interpret the residual plot. We know what a residual plot looks like. We know how to get the residuals to draw it. But if your residuals are randomly scattered above and below the x-axis, then a line is appropriate. So if you look at this, is there any pattern to the dots on that residual that I've circled? So that would mean that if I drew a line of best fit through the dots, there'd be some dots above, some dots below. There wouldn't be a nice pattern to it. Linear is okay there. But if you look at these residuals, is there a definitive shape to how those dots go?
Yep.
A below? Slightly above, more above, there's a curve to that. It looks like a sad face. This one, what do the residuals do? Smiley face. This one, the residuals form a straight line. Do these look random to you? No. If you see a nice pattern in your residuals, line's not going to be okay. Because if we look here, when we first started this lesson, you thought linear was going to be good because those dots were close to the line. But if I did a residual plot of this, would you have a residual that was well above the x-axis? You'd have one that's slightly above it. You'd have one slightly below. What's the residual plot of this going to look like? The residual plot for this graph is going to look like this. See how there's a shape to it? So that's telling you, okay, we looked at r squared. R squared, maybe linear is okay. Then I draw a residual plot and I see a pattern to that. That indicates that a line is probably not the best model for this. Is there a pattern to the residual that we just drew? Can you see a sad face there? It's not random. It starts off low. It goes up even higher. There's a peak. Then it comes back down. So what's our interpretation of that? Linear is, it looks like this. Linear is not going to be okay. So that's the answer to C. Using the residual plot, is it appropriate to use a line model to represent the data? No, because the residual plot has a clear pattern. Look, if we know the residual here, we could sort of guess what the scatter plot would be. That line in the middle represents a line of best fit. Where would the dots sit? You'd have one well below it. You'd have one dot slightly below. You'd have a dot above. You'd have a dot well above. You'd have a dot slightly above, slightly below, well below. You can see the data is forming a curve. It's not forming a straight line. Right? So what is the purpose of a residual plot? It's like a second scan to go, right now, r squared is telling me, r and r squared are telling me that a line is probably appropriate. But if I draw a residual plot, we reveal a pattern there. Linear is probably not appropriate. Okay? So all I want you to do today is 4F1 and 4F2, those answers there. That's kind of long. This question type only pops up every so often, but I can't skip anything. Okay?